In the last video we covered carbon-13 NMR. In this video we're going to go over Proton NMR. So what is the main difference? The main difference is that carbon-13 NMR focuses on the carbon environments in the molecule, whereas Proton NMR focuses on the hydrogen environments in A. So Proton NMR works in the exact same way as carbon-13 NMR. So you have a test tube with your sample that you're analysing, your solvent, which is CdCl3. Just to recap, that's used because deuterium has an even number of neutrons, so it will give no signal, therefore meaning no peak will appear on the spectra. And TMS as our reference molecule. So the example molecule we're going to use in this demonstration is ethanol. I'm going to ask you to pause the video and have a think about how many proton environments there are in ethanol, and when you resume the video I'll go through the answer and give an explanation. Like in the last demonstration, we need to look at the different environments, but this time the proton environments as opposed to the carbon environments. Hopefully you came to the answer of 3. Why is this? This is because, I've done it in a different colour. This proton here is connected to an oxygen, that's the only one of its kind. CH2, this proton is connected to hydrogen, which is connected to one of a proton. And finally, the last environment, these protons here, they're connected to a carbon, which is also connected to 2 other protons, giving the 3 different proton environments. Okay, so now we're going to look at the spectra itself. So we've got chemical shift along the bottom, remember, and we have 0, which is the TMS reference peak, and then of 1, 2, 3, 4, 5, and 6. So we've already identified how many different proton environments there are, and we've identified that there's 3. So now the second step, like before in the previous demonstration with carbon-13, we need to look at the chemical shift values to see what kind of groups we have. In an exam situation, or when you're doing any assignment, or even if you're doing it just for practice, you should always be able to find a carbon-13 and a Proton NMR data sheet, chemical shift data sheet. In this case, I've researched it and found out the following chemical shifts values for each different group. So the alcohol group gives a chemical shift value of 1 to 2 parts per million. And the CH2, 2R groups, comes up with a value of about 3 to 4 ppm. And the OH group is a very broad range of about 1 to 6 ppm. Okay, so we'll complete the spectra now in the respective colours. So the CH3 group, the alcohol group, I'm going to put a peak there. And the CH2 group, around 3 to 4 ppm, just in the middle there, single peak for that. And finally the broad OH group, 1 to 6 ppm, so I'll aim for about 3. So that is the complete spectra for ethanol. Okay, so moving on, I'm going to draw out a molecule, and then once I've drawn out the molecule, I ask you to pause the video and calculate how many different proton environments there are, and then resume the video and we'll go through it together. I feel like this is important to just get practice identifying how many different environments there are, because that's a large part of being good at analysing nuclear magnetic resonance graphs, spectras, because you see how many peaks there are, that's the equivalent to how many different environments there are. So if you get good at identifying different environments, then you're halfway there to being successful at analysing NMR spectras. So the following molecule, Okay, so pause the video. And so hopefully you came with the answer of 5 proton environments. Reasons being, so number 1, this proton's connected to a carbon, which is bonded to 2 other carbons and an oxygen. Environment 2, this proton's connected to an oxygen. Proton environment 3, these protons are bonded to a carbon, which is bonded to a carbon with a proton and an oxygen. Environment 4, CH2 group, these protons are in the same environment, so they're connected to 2 carbons, and one of them being a carbon with a hydrogen and an oxygen, and a methyl group. And then the last environment are these 3 protons here, because they're connected to a carbon which is connected to a CH2 group. In an exam you could get a question saying, is different types of butanol with the alcohol group in different positions, and then you get the spectra, which alcohol is shown in the spectra. So a quick easy way to do it, identify how many environments there are in the spectra. So say if there's 5, then look at the molecules, draw out the structure, work out the environments, and then they may have different amounts of environments, so it will narrow it down to either 1 or 2 different structures, or even 1 in some cases, and then therefore that's the answer. That's what I want you to take away from this video. The number of hydrogen environments can be worked out from the number of peaks on the spectra, and the type of environments are given by the chemical shift value. So you can see how closely interlinked carbon and proton NMR is. Thank you very much for watching my video. Just remember, in an exam situation, if you get a difficult question asking you to analyse any NMR spectra, just write all the information you can, even if it's just identifying how many different carbon or proton environments there are, because that's bound to get you marks for your understanding, even if you cannot come up with the final structure. Studies that practice makes perfect, like most things in life, but you know, just get yourself a molecule. You can find so many different spectras online. Just type in spectra of ethanol and look at it and try and identify why it looks how it does, or maybe try and draw the spectra from scratch, or maybe get a spectra of an unknown compound and then try and identify the compound. The 2 types of NMR interlink quite a lot, so they both have a similar format of how you go about concluding an answer. So you're looking at the different types of environments, the number of environments, and then identifying the different types of environments from chemical shift reference tables or charts. Wish you all the best with solving future NMR problems. I hope this series of videos has given you a good solid foundation of knowledge and a good basis to build on, and I hope you feel more confident in solving and interpreting NMR problems in the future.